I would say overwhelmingly, the next thing we talk about for some people is one of the hardest things. This is one of the things that on the AP exam throws students off because it doesn't come up all the time. I've seen problems like dealing with combining random variables in both multiple choice and free response, and almost overwhelmingly, they are the lowest scoring problems on the exam. So we'll do our best to make sure to review as we get closer to the exam so we don't forget. On FRQ, they're generally embedded in like an A or a B part of a full question. I do have an old question that we'll look at hopefully next week, so you can kind of see where it would show up in FRQ. So in regular math class, in regular algebra, x plus x is equal to 2x. But in statistics and random variables, x plus x does not necessarily equal to 2x. You don't have to write that down. Okay, because remember that a random variable can hold different values, right? So if, for example, I have some random variable that holds, 3 potential values, I could say that the first x is a 1, but the second x is a 2. I could say that the first x is a 1, but the second x is a 5. And so on, right? You don't need me to continue that idea. But so each of these two x's can have different values. That's what makes them be a random variable. And so the laws of algebra don't apply to random variables all the time. Is it true that sometimes this will be a true statement? Yeah. When x is 1 and x is 1. When the first random variable is 1 and the second one is 1. But that's not always going to be the case. Okay, so let's talk about what happens when you combine random variables. Okay, so here we have 2 random variables, x and y, with their probability distributions. Let's find the mean, the variance, and let's do the standard deviation too for both of these random variables. So go ahead and take a second. If you want to divide and conquer, please do so. Let's find the mean, the standard deviation, and the variance for each. Okay, let's go ahead and, in the interest of time, I'll help you out. So, did anybody find the mean of x? How about the variance? And the standard deviation? 1.55. Okay, anybody get to the mean of y? 2.6. Sigma, variance? What did... Anybody get that far? I got 0.84. Did we get any verification on that? Yes? Okay. And then 0.92 is the standard deviation. Okay, so nothing new here. Question number 2 says to build a new random variable, which is the sum of the 2 random variables x and y. Okay, I purposely did them separate named so that it wouldn't be necessary. Hopefully it'll just make it be more clear. Okay, but they can be named the same. I could name a new random variable as x plus x. Okay, so here I have this new random variable. And what I want to know is what are all the possible values that x plus y could obtain? Right? If x is 1 and y is 2, then x plus y is going to be 3. So I made this little Punnett square for you so you can see all the different possibilities. So if x is 1 and y is 2, then the new random variable is 3. If x is 2 and y is 2, then the new random variable is 4. If x is 5 and y is 2, then the random variable is 7. In the next column, what would we get? 5, 6, 9. Okay, so these are the 6 possible values that this new random variable can have. Okay, and we could name it something else. We could call it like A. Random variable A is x plus y. And so now we want to set up a probability distribution to represent A. So I take all the possible values that A can have, and I put them in order from left to right. So 3, 4, 5, 6, 7, and 9. Okay, so now we want to calculate these probabilities. So I'm just going to take a little, I didn't leave us a lot of space. Let's think about where this one came from. So x plus y was equal to 3. That was coming from x equal to 1 and y equal to 2. Right, that's where that came from, right here. X was 1 and y was 2. Okay, think back to chapter 5 for a minute. So if I have an and situation, how do I deal with the probabilities? Does and mean to add or multiply? So this is probability of x equal to 1 times the probability of y equal to 2. Do I just leave it, or is it y equals 2 given x equals 1? There is a given, but are they independent? If I tell you some information about what x is doing, does that inform you about y? No. Oh, goodness. Thank goodness. This is just y equals 2. So, right? That's what it means to be independent. Chapter 5 test Wednesday. Yeah, that was 2 days ago. Today's Friday. Okay, so what is the probability that x is equal to 1? 0.2. What's the probability that y is 2? 0.7. When you multiply them together, you get 0.14. Okay, that's where this probability is coming from. Essentially, you're just multiplying the two numbers together. Okay, but why it is because of the formulas we talked about in chapter 5. This is why we had to talk about probability. Okay, so then how about here? When a, or x plus y, is equal to 4, that means x was 2 and y was 2. I multiply their probabilities together. So we take 0.5 times 0.7 to get 0.35. This is coming from over here where x was 1 and y was 4. So what two probabilities are we multiplying together? 0.2 and 0.3 to get 0.06. What two probabilities multiply to get this? 0.5 and 0.3. So 0.15. What's the next probability? 0.21 and last? 0.09. Is it a valid probability distribution?
Yes.
Are you sure?
Yeah, they are.
Well, this is 31.
No, that's 30.
This is 30. Good. Just testing you. There's 30, 65. This is going to be 20. So 85 and 15 is 1. Okay, great. So what about now? What if we take this new probability distribution and compute the mean of this new random variable? So the mean of x plus y. Okay, well, let's do that. 3 times 0.14 plus 4 times 0.35, and so on. I got 5.3. How's that related to the mean of x and the mean of y?
You add them together.
Say it again, Chris. Yeah, what if you add them together? What's 2.7 plus 2.6? 5.3. Okay, so this is no, like, it's not a surprise. This is not an accident. This is a formula you should know. So if I have two random variables that are adding together, I can find the mean of this new random variable by adding their separate means. Does that apply to variance and standard deviation? I don't know. Well, let's see. Is it in fact true that if I take the variance of x plus y, that I get the variance of x plus the variance of y? Okay, well, I'll do the part over here on the right. The variance of x from above was 2.41, and the variance of y from above is 0.84. And when I add them together, I get 3.25. Okay, so then if I want to find the variance of my random variable, okay, well, we'll just do some quick calculations here. Let's see, 3, 4, 5, 6, 7, and 9, 0.14, 0.35, 0.06, 0.15, 0.21, 0.09. Okay, variance calculation is going to be the sum. I'm going to take L1 minus 5.3 quantity squared times L2 to get the variance. So this is another rule. So the variance, when I combine by adding, means that I can add their separate variances as well. Now, because this is a conditional probability, this is only if the random variables are independent. Okay, I'm not going to go further than that. You can take some advanced statistics, and there's a different formula if they're not independent. You don't have to know that. Okay, so what about standard deviations? Does this apply to standard deviation? Does the standard deviation of x plus y equal the standard deviation of x plus the standard deviation of y? Well, we just found the standard deviation of x, the variance of x plus y to be 3.25. So I can take the root of 3.25 to get the standard deviation of x plus y. And over here, if I separately add together the standard deviations, the standard deviation of x from above was 1.55, and the standard deviation of y from above was 0.92. Are these two things equal? No. This is 1.8 versus 2.47. So this is the key thing. This is a place where students historically mess up. You cannot add standard deviations. You can only add variances. Okay, so when you're ready, we're going to flip over. And I'd like you to start filling in the table. Can you then look at a new random variable called x minus y? Do these rules apply if we have subtraction?
Eraser, you're using a pen. Judge.
All right, so if we have x minus y here, what is the value of the new variable? -1. Down the column, 0, 3. Next column, -3, -2, and 1. So these are the 6 values that this new random variable x minus y can have. You want to put them in order. And we would calculate their probabilities in the same fashion as we did before. So -3 was when x was 1 and y was 4. So when x was 1, I had 0.2. When y was 4, I had 0.3. This is 0.06. I'll help you out here. This is going to be 0.15, 0.14, 0.35, 0.09, and 0.21. What's the mean of x minus y? Zero 0.1. Question? Oh, you mean right here?
Yeah.
So we kind of talked about that. Did I not have that on the other page?
No, you said no.
Oh, I said it out loud. I just didn't write it there. So this is, you can write it as a conditional, right? I can say y equals 4 given that x is equal to 1, but we know that they're independent, and so that really just means that this is p of y equals 4. Okay, so the mean of x minus y is 0.1. How is that related to the mean of x and the mean of y? Yeah, you subtract them. Mu sub x minus y is equal to mu sub x minus mu sub y. That's cool. Now we would love to say that the variance of x minus y is equal to the variance of x minus the variance of y. But that's not true. Regardless of if you add or subtract the random variables, you always add the variances separately. This would be equal to 3.25. So the variance doesn't change from x plus y to x minus y. Okay, so I just wanted to speed up our process here. You could plug this stuff in to lists L1 and L2, and you could do your calculation for variance, and you're going to see that this calculation is going to get you to 3.25. So generally speaking, here are the formulas you have to know for combining random variables. If I have the mean of x plus or minus y, it's the mean of x plus or minus the mean of y. So if I'm adding, I'm adding. If I'm subtracting, I'm subtracting. And this formula is for independent or dependent events, for all events, aka random variables. right? We're talking about random variables now. The variance, however, x plus or minus y, is always the standard, the variance of x plus the variance of y. And this is only for independent events. Like I said, you would have a different formula if they were dependent events. So that's one of the things that we have to be careful of. I can't calculate a standard deviation or a variance unless my events are independent. So we're going to go back to the notes packet and take a look at a couple of examples. So back to the community college. So let's suppose that the community college has two campuses. It has the main campus, which we talked about already on the previous page. Here's the distribution of units for the main campus. And let's say that they also have a downtown campus. So we're going to let X be the number of units at the main campus, and here we have Y being the number of units taken at the downtown campus. Here's the probability distribution. I'm going to help you out by calculating, just in the interest of time. The mean of Y is 15 units, and the variance of Y is 5.4, which implies that the standard deviation is 2.3 units. We could interpret them. This means if we take many, many students from this community college, that on average that student would be taking 15 units. Here we've got the standard deviation. The number of units taken by a randomly selected student typically varies by 2.3 units from the mean of 15. Okay. So if a question asks you then to consider some combination of random variables, here it's saying, let's randomly select one full-time student from the main campus and one full-time student from the downtown campus, and look at their number of units, the sum of their units. Find the mean and the standard deviation. Okay, well, the mean of S is really just the mean of x plus y, right? We've defined S as x plus y. So then I can take the mean of x plus the mean of y. Do you remember what was the mean of x? 14.65. And what was the mean of y? 15. And so we get 29.65 units. Now, for me to calculate standard deviation, I have to consider if they're independent. Okay, I can only calculate standard deviation or variance if they're independent. So before I even go to calculate, I want to test or check or have a little conversation with myself about whether or not these situations are independent. So let's think about this. Is it reasonable to believe that X, the number of units taken in the fall semester by a randomly selected full-time student at the main campus, is independent from the number of units taken in the fall semester by a full-time student at the downtown campus? If I tell you how many units are being taken by a student at the main campus, does that inform you about how many units another student would be taking at the other campus? No. I mean, could there be some what-ifs? You know, what if they are brother and sister? And so they have, like, whatever. What if they work at the same job? Okay, like, there's things that are, like, so minuscule in terms of the what-ifs that we're just going to ignore those. In general, does it seem to make sense that if I know something about the main campus students' units, that it wouldn't tell me anything about the other campus students? So then I think it's reasonable to say it's independent. And so that's all you have to say. Like, I don't have to know for sure. All I have to do is say it's reasonable. It's reasonable to believe that the number of units students take at each campus are independent of each other. And so now that I know that, or now that I've proclaimed that, then we can calculate the variance. Remember that we can add variances. We cannot add standard deviations. So we have to do the variances first. So variance is just the standard deviation squared. We found the standard deviation to be 2.06. So this is going to be 2.06 squared. And the variance of y is just right here. You could take 2.3 and square it. And we would get 9.6. That means then, therefore, the standard deviation, oh, I should just call it S, is the root of 9.6, which is 3.11. So here's your standard deviation. So they're going to try to trick you. If you just read through the next example, it says, let B be the amount of money spent on books in the fall semester. And remember that you've got an overall cost for tuition and fees. So would the tuition, the costs, the fees, and the books, would all of those things be independent of each other, or would they be related? They're related. So if I'm taking more units, then it's probably going to cost more. So can I calculate the mean and the standard deviation? It says find the mean and the standard deviation for tuition, fees, and books. Well, you can find the mean. I could find the mean. No problem. But I cannot calculate the standard deviation or the variance because it's not reasonable to think that these are independent. Oops, sorry. Okay, so I have one last example for you. We're going to skip the problem on roulette on the next page. We'll take a look at that next time. Let's talk about Tom and George.